6.4, Dividing Polynomials, Long Division. So you might remember long division from, like, I don't know, grade school? I don't know. I can't even remember when we learned that. Like 5th or 4th, 3rd grade, something like that. Anyways, so we're actually going to use long division today. And if you have a hard time remembering, I'll go over it a little bit for you. Anyways, dividing a polynomial by a monomial. So divide each term in the polynomial by the monomial. So if we have a polynomial on top and a monomial on bottom, we just separate it, and c can never be 0. So in example 1, you see on top how we have a trinomial, and on the bottom we have a monomial. So we're just going to separate and put the bottom on each, because since it's under everything, we can separate it. So we separate it, and now we can start canceling out. So top and bottom, only top and bottom, because there's a minus and a plus there, only top and bottom. So top and bottom, 12 divided by 3, we're left with 4. A cubed, 1a, so we only take 1a out. 36 divided by 3, that's 12. And then here we can take a's out. And then 15 divided by 3 is 5. And we can't cancel out the a, so let's just write what we have left over. We have negative 4a squared over nothing. So if it's over nothing, if nothing's left, you just leave it as the top. And then next we have 12. That's it there. There's nothing left over. And then minus 5 over a. Rewrite that 5. And that is our final answer. That's simplest form. Alright, I want you to take a moment, pause, and try the next one. Okay, try the next one. I hope you tried it. If not, that's okay. I understand, like, you're like, I need to see another one, but should just try. If you get it wrong, you get it wrong. It's okay. So the first thing that I hope you did was separate everything, because we have a polynomial on top and a monomial on the bottom, so we're going to separate it. We have 10t to the 4th over 5t squared minus 35t cubed over 5t squared plus 5t squared over 5t squared. Alrighty, let's start canceling out. So 10 divided by 5, we're left with 2 on top. We have t to the 4th and t squared, so we can only take out 2 t's. So we take out 2. 35 divided by 5 is 7. T cubed and t squared, we can only take 2 of them out, so when we take 2, we're only left with 1. And then 5t squared and 5t squared, those are the same exact numbers. When they're the same exact numbers, they do cancel each other out, but we're left with 1. So it's just like 4 over 4, isn't that 1? So 5t squared over 5t squared, that's still 1. Alright, now let's write what we have left over. We have 2t squared over nothing, so minus 7t to the 1st. You don't have to put the little 1, I'm not going to, but only 1 is left. And then plus 1. So I'll rewrite that. We have 2t squared minus 7t plus 1. And that's our simplest form. Alright, dividing a polynomial. So dividing a polynomial by a polynomial other than a monomial uses long division. So basically, if you don't have a monomial in the bottom, you can't do it this way. So when you have polynomial over polynomial, we can use long division. And it's very similar to like the long division we would normally use as numbers. So this is kind of like our review of long division. I'll go over it with you. So, right, we look at how many times does 43 go into 72? One time, right? So 1 times 43, we get 43. And then we subtract, right? So don't we put that little minus and we subtract? So we subtract and we're left with 29, and we bring the 5 down. So then we want to know how many times does 43 go into 295? Well, it goes in it 6 times. So 6 times 43, we get 258. Subtract, we're left with 37. We bring the 6 down. So how many times does 43 go into 376? It goes in 8 times. And then we have a remainder of 32 because there's nothing else we can bring down. So you might remember that. Hopefully it sparks some memory. If it doesn't, if you're like, I have no idea what you're talking about, just go on YouTube and look up dividing numbers or long division, and take like 5 minutes, just get that ball rolling again. It's like when you haven't ridden a bike in a long time, or when you and then you get on, it's like a little shaky and weird, but then once you start pedaling, you got it. That's very similar to especially like things like this in math. So just review it a little bit and it'll start to come back. All right, let's use long division. So bear with me and we're going to take it slow. Long division does come back often in math. It's something we're going to use. You will use this thing that we're doing again in 5.2 in college algebra. So it does come back. All right, we only look at the first term. Only the first term. So I want to make it the same by multiplying. So what can I multiply to 7 to be 28? I can multiply by 4. Now I need my x's to be the same. So how can I make x be x squared? I have to multiply by x, right? So now I multiply it back out. And when we do, we have 4x times 7x is 28x squared. 4x times 3 is positive 12x. And remember, when we multiplied it back out, didn't we put that little minus sign? So that's what we're going to do, except we have to flip the terms, because a minus, when you minus it, you're actually making the term opposite. So we have to take the opposite of these. So 28x squared becomes negative, and positive 12x becomes negative 12x. And then from there, we add. So these will always, the first one will always cancel out. We bring everything straight down. So negative 23x minus 12x. So remember, it turned into a minus. So we're left with negative 35x. And we bring down the remaining term, minus 15. We're going to do it again. Like literally repeat our steps. So we're only going to look at our first terms. So what can I multiply to 7 to make it negative 35? I have to multiply by negative 5. X and x, they already match. So we're good. We're good there. X and x already match. So we're going to multiply it back out. So we have negative 5 times 7x is negative 35x. Negative 5 times positive 3 is negative 15. Now we're going to switch all the signs. So negative becomes positive. Negative becomes positive. We're going to add straight down. So negative 35x plus 35x, that cancels. Negative 15 plus 15, that cancels. We're left with 0, meaning we do not have a remainder. That means our solution, factored out and simplified, is 4x minus 5. Did you know we just factored? That's what division is. You're just factoring. So the factors, if we were to factor 28x squared minus 23x minus 15, the factors would be 4x minus 5 and 7x plus 3. Those are the factors. So you can use long division if it perfectly factors. If there's a remainder, you can't factor it anyways. If there's no remainder, you have to use the quadratic formula. So just wanted to throw that out there. All right, let's do this again. So only ever looking at the first terms. So 2x to 4x squared. So I need to be 2 to be 4. So I need to multiply by 2. Now I need to make x x squared. So I need to multiply by x. I'm going to multiply it out. And when we do, we have 4x squared plus 14x. Now we need to switch the signs. So positive 4x squared becomes negative 4x squared. Positive 14x becomes negative 14x. And our first term cancels. That's our goal. That's why it's always going to happen. It's our goal. So we have negative 6x minus 14x. And we have negative 20x. And we bring down what's left. So plus 8. And then we just do it again. Repeat that process. So we're only looking at the first one, 2x and negative 20x. So I need 2 to become negative 20. So I need to multiply by negative 10. X and x, they already match, so we're good to go. Now we multiply it back out. So we have negative 10 times 2x is negative 20x. And then we have negative 10 times 7 is negative 70. Again, we're going to switch the terms, or switch the signs. So negative becomes positive, negative becomes positive. Our first term cancels. That was our goal, because negative 20, positive 20x. And we have 8 plus 70. That's 78. How do I know I'm done? Can 2x ever be 78? Numerically, yes, but the 78 does not have an x. So 2x can never multiply to 78. So that's what we call our remainder. So how we write our remainder, I'll show you. So on top we have 2x minus 10. The remainder, since it's plus positive 78, it'll be plus 78 over 2x plus 7. So that's our remainder. Like, we put that over. Our remainder, we put it over what's on the outside of the house. So we could not factor this. That's actually, it's impossible to factor 4x squared minus 6x plus 8. That's why we have a remainder. Alrighty. Now we're looking different. This is still division. How do I know it's still division? Because it's a fraction. Remember, fraction is just division. So we draw our little house or garage, however you learned it. I learned it as the house. The top goes inside the house. And the bottom goes outside the house. And let's repeat our process. Only the first one. So c needs to become c squared. So I need to multiply by c. You multiply it back out. So we have c times c is c squared. C times 1 is just, you can put 1c. Put 1c if you have to. That's okay. It's the same thing. We switch the signs. So positive becomes negative. Positive becomes negative. C squared minus c squared, they cancel out. 3c minus 1c, we're left with 2c. And we bring down the negative 2. And let's repeat our process. So I need to make c become 2c. So they already have the c, it's just missing the 2, so I need to multiply by positive 2. We're going to multiply it back out. And when we do, we have 2 times c is 2c. They match good. And then we have 2 times 1 is 2. We need to switch our signs. So positive becomes negative. Positive becomes negative. 2c minus 2c, that cancels. Negative 2 minus 2 is negative 4. And that's our remainder, because c can never be negative 4. Like, that's a variable and that's a number. It's never going to happen. So that's our remainder. All right, so now our final answer is c plus 2. And there's 2 ways we can write our answer. I'll show you. We can do, because it's negative, we can do minus 4 over c plus 1. This is like the better way to write your answer, but another way to write your answer would be c plus 2 plus negative 4 over c plus 1. But to be real, like the boxed one, that's simplest form, because plus minus, we never do that. But I mean, if it were a paper test, I would accept either. It doesn't matter. But my math lab is going to accept the box one only. Alrighty. So let's set this up, and then after we set it up, I want you to try to do this on your own. Okay, so let's set it up. So we're going to draw our garage, draw our house, however you like to call it, it doesn't matter. So the left goes inside, and the right goes outside. Alright, so before you pause it, I will give you a hint. There is not a remainder. No remainder. So go ahead, pause it, try it. Alright, I hope you're back. If not, pause it. Please do try this on your own. Okay, let's do this together now. Alright, so we need to make y become y squared. So I need to multiply to that. So y becomes y squared by multiplying by y. We multiply it back out, and when we do, we have y times y is y squared. Y times negative 2 is negative 2y. We're going to switch the signs, so positive becomes negative, negative becomes positive. Y squared minus y squared, that cancels, that was the goal. Negative 5y plus 2y is negative 3y, and we bring down what's left over, positive 6. Alright, now we need to make y become negative 3y. So they share the y. That's already there. They share that. Awesome. What they don't have yet is the 3. So I need to multiply by negative 3. So negative 3 times y, we get negative 3y. Negative 3 times negative 2 is positive 6. We're going to switch the signs. So negative becomes positive. Positive becomes negative. We have negative 3y plus 3y, that cancels, that was the goal. Positive 6 minus 6, we have 0, so no remainder. Our answer is y minus 3.